press.
No, the fork is the plate. Fork and plate. We need something very strong, but small. Smaller than this. I gotta go down the thickness of that to get it out. So let's go get some pushing bar. So we put a bunch of boxes in the way. I need to turn sideways at some point so I could get by. We need something like one of these. Nice if I had a piece of bar stock dedicated for that. So I don't crush my good material, because it's going to crush these. We'll put enough pressure on there, it's going to work it over. Looks like that one will fit just fine.
So did you just grab a pressing die that is just under the diameter of that pin?
Yeah.
For even pressing?
And then you press on it with something like that. Help protect it a little bit. So this is cut out in a big YU. So it slips in there. The flat part of the flywheel up under there.
Mm-hmm.
Now these wheels weren't quite 100% flat in there. I think that's some stuff they were doing around in there, but it seems to be pretty flat.
Yeah.
That's all I care about. The gears on coming up half the crankpin on the other side,
Mm-hmm.
which is going to make it kind of fun to put it back together. Not sure how that's going to work. So basically I'll have to use another plate like that with a circle cut in it.
To get it back in.
Yeah. So I might have to take my tool here and modify it.
Mm.
This big donut, like we did that big plate over there.
Mm-hmm.
In fact, I don't want to weaken this anymore. I have to, because every time I cut out this, it weakens it.
Mm-hmm.
So right now, with the flywheels I've done on it, I've already got this bowed slightly, because it's a little bit higher, like this right now.
Mm-hmm.
That's why I put it this direction, because we only got like 6 inches of metal here.
Strength back there in the back.
By 1.5 inches or 1.25 inches, whatever. That's probably 1.25 inches by 6 inch. So over the tonnage I'm using, it's slowly bending it.
Mm-hmm.
So right now I just reverse it, so it should bring it back down.
Right.
It doesn't matter on the U how it's done. Now I cut the U wider, which is going to weaken it slightly too. But basically the weakest point's right here.
Mm-hmm.
Doesn't matter how wide it is here. It can come all the way out to here. The weak point's still here. Until you get less than 6 inches somewhere, that's the weak point.
Right.
So that's how it's going to go. So we'll see what the tonnage is for this. So I'm going to put this in the center. Looks like it's centered. These blocks are on the other side of the press supporting this one. These are here so it can just drop without doing damage. And it should just go straight down. I got this shoved in as far as I can to get the most strength. So many tons is it going to take to move it?
How many is that? 5?
I think we're going to have to go to higher pressure. 10. 15 it moved.
That it did.
That's not very good. That's pretty low.
Well, it's dropping now.
Yeah, we had so much
as it's pushing
15
through
ton pressure. Remember how it took us that tool?
Mm-hmm.
The good one's 23 tons, 22.
Right.
But that's a twin cam, not a M8.
So what if 15 tons is when it moved?
Yeah. 15, 16 right there.
So somewhere around there we made it to 15 tons
Well,
of some type of something.
We barely moved it. It's all we could do to move it, and it wasn't, so you get an idea how far off we are. That's not much. So I'll guarantee S&S and Ultimate have a lot stronger press fit than that. And I haven't found my tools yet for putting this back together yet either, so. You see how polish is in there where it's been pressed in. So. You still see the marks in there from machining.
Mm-hmm. There's an oil hole right there.
This is pretty flat when we put it in.
I would assume those oil holes have to line up when we put it back together.
Well,
correct?
yeah, if the flywheel is straight, it will be lined up. That's a minor problem. So, that's that one. Now, our problem right now is called your rods suck. The problem is when these things are tight like this, they don't come off. You got to press them off. But I can't push the crank pin out of the other side because the gear is over there.
Mm.
So now I got to figure how I'm going to pull the rod off. And I don't know if I can do that. That's going to be a problem.
The big jaw puller won't pull them off?
I got to get to it. You got to be able to get to it before you can pull it. Next problem is this is in the way, so I want this to drop. If you go over center, it hits the floor behind you.
Mm-hmm.
I've done that before. And I'm hitting under here with the main shaft, so I'm going to move just enough to get it out, see? You got to pull this back. That's your work surface. See, normally I just push the crank pin out this side,
Mm-hmm.
but I said I don't want to take this gear off because then I'll have to do it. Now how do I put the crank, how do I push this back together when I don't have access to push evenly on that crank pin? Because the flywheel will cock on you like that and it'll screw up the hole, won't go in straight.
Mm-hmm.
So right now when we put this back together, we got to have pretty good coverage here to keep that flat. So all I can do is put a block this way and a block that way, and hopefully that's straight enough to hold it. And
Right.
it's going to be pushing on this just a little corner here because I don't want to hit that gear. Now if we have to pull the gear off, then I'm going to have to make some kind of a tool for alignment so that it lines. Now there's a dowel over here that looks like it's in the flywheel. So we have to have a certain space right in there, which I can probably duplicate pretty easy with a drill bit. And now I just got to figure out where, if there's any kind of a timing mark, so I'll probably wind up just marking it right next to where it goes.
Well, there went the bearing.
Yeah, we'll have to find those later. That was the easy one to come off. This male rod's the problem.
And that has too much of a curve on it to bite onto, I'm assuming.
I think there's enough I can bite onto that. See, the rods are in the way, so
Mm-hmm.
I think there's enough there I can work with it. Okay, where's our tranny case?
Right over here.
Our flywheel holding fixture.
Where would you like it parked?
Right in the middle. Except that gear
That's fine.
sits like that. Okay, so I only got that one set of big clamps that I found so far, so there's more somewhere. Don't know where they're at, though. They're around. They're right in front of you.
That they were.
It's just you got to figure out where the front of you is at. Dad had some big ones too, but they're
Back there.
back there someplace.
Yeah.
Alright, my small one's not going to open anywhere near that big enough, so
What's that?
let's see what we got to do with this big ass one here.
You saying that little one right there ain't gonna open that big?
Nope.
I think so.
Nope. That ain't going to go that big, I don't think. But this one will. What do you tell me?
So what the hell does that clamp onto to pull it up? That thing over there?
The other half of the tool over there.
Oh.
No problem.
You just gotta go under the rod.
problem here. The rod's in the way. I knew the rod was going to be a problem. I don't think this is going to work.
Whammo blammo. Nope. Still sits too low.
Yeah, rods are in the way. So I can't use anything like this. So then we have to get more ingenious. So these are 2-0-4 up there. Alright, look out. Fit back in there. I'm going to use this. Sure. The clamp. I need my center off the table over there.
The hootie, what?
Yeah, that centerpiece.
Oh,
Remember that guy?
yeah.
Yeah, it looks like it fits the same way as the other one. It's going to be long enough or not? Oh yeah. See the problem?
Mm-hmm. The radius is too big at the bottom of them. Coming up.
There you go.
There's your press fit. So when you put rods back together, is there a certain way they go back together?
Yeah, not tight.
No, like directional wise.
Yeah. Back one's back, front one's front. Okay, put that back. Okay. There's my holding fixture.
Took this where I got hot.
It's induction hardened. These are made out of garbage material. They heat them up real hard with induction, and they quench them.
Mm-hmm.
Not rebuildable, not replaceable. So, these are not really repairable. One and done. They're on the way. So if they're flaked at all, we can't use them. And you can see how little bearing area you actually have.
Mm-hmm.
The rest of this wear you see here is from the rod rubbing on it.
Mm-hmm.
The shiny spot is, the gray spot in the middle is all the rollers. So you only got about 1/3 of that material is being used for bearing surface. Everything else is for show. Harley doesn't want to give you anything good. They could very easily make a really good cage and expensive and make that bearing surface 2/3 its surface, but no, why would you want to do that? And this one you can see even half this, the cage is not even touching.
Mm-hmm.
So, like I said, once these things start to flake and I can't do a damn, there's nothing I can do. So I'm not seeing any pitting yet. So they should still be repairable. They're out of round right now badly. So I can go all the trouble of putting a gauge on there and measuring it. And I just hold them until they work. Guess which one I'm going to do?
Hold it till it works.
There you go. I don't care how far around it is because I can't fix it. There's no oversized bearings.
No.
Now, usually there was a marking or something, so the only mark we got is this one. And there's one here, so I'll put them together like that. I put the marks together. This rod doesn't matter which way it goes in, it's universal.
That was the question.
It looks symmetrical to me, or is it offset slightly? So go get my scale. Tape measure. Give me a tape measure. So if you go off the center of the rod here, center rod there, is the rod going down the center. Looks like it's the same to me. What do you think?
It looks about the same.
Yeah, not offset. So it doesn't matter how it goes, either way. Goes in there, it's got clearance there, which is good. Wasn't too bad. Look how they make that rod. That's stupid. So the load on the rod's down here. Where's all the material at? Up there.
Mm-hmm.
Stupid.
So why did they make that hole what looks to be oblong?
Because these are just forged out and you drill where they're going to be.
And wherever the hole is wherever it stays, huh?
The forging's not made very good, obviously. See, this rod was longer than it was designed to be. See, they made it for a shorter rod length.
Mm.
So they just moved the hole down and use the same forging. Wrong. So that weakens the piss out of it, so it gets out of round.
Mm-hmm.
And remember, this is the rod that was pressed on because it's the one that's out of round the most.
Because it's so thin right there.
What happens is they go oval shape like this. So they press on the side and they're loose top to bottom. But you can't feel it because they're so tight on the side.
Right. It won't allow you to.
Yeah, you can't feel the clearance. Now, if that wasn't there, you could get a little up and down, but you can't feel that. So all I'm going to do is I'm just going to hold it out to make it round again, and that'll make it so it's free to float. And if you keep driving hard, it's going to keep stretching. But that rod obviously is not made very good. It sucks. Now, is the other one made the same way or different? I don't know. And there's also two different rod lengths on the twin cam.
Mm.
Now on the M8, I'm assuming they're all the same. Now, do they make the rods longer on a the M8 than a twin cam?
Mm.
I don't know either.
Don't you have a twin cam rod?
I had one in a drawer over there. A male rod, or female rod. We know they're different diameter. We had to modify my jig, remember?
Mm-hmm.
So this is physically bigger here. This is an X beam, they call this.
Why is it called an X-beam?
Because it's a combination of an I-beam rod and an H-beam rod.
Mm.
So they call it an X. Newest way of doing so. Basically, it's a very deep, when you start putting a deep channel in it, you start calling H and then an I-beam.
Mm.
See, I-beam is low side.
Right.
This one's high side. So when you start seeing high side, you call it H. So instead of the H being this way, like aftermarket rods are, the H is this way.
That way. Yeah.
This is the stronger way. Sideways like this is not the strong way to
Not
build
the
a rod.
stronger way,
It's
yeah.
the cheap way to build a rod. So that's how the aftermarket does it. And they see how great it is. No, it isn't. I-beam is stronger design-wise. Now when you make it real stick through here, that makes the rod strong. So
Doesn't flex left and right.
you have good strength this way.
Right.
I-beams bend really easy one way. So the I-beam's up here,
Mm-hmm.
up. when you have them like that, they'll hold. They don't have much bending to them. Bow. If you flip them sideways and do the same spread, they'd bow in the middle real heavy. Because the strength is this direction, not sideways.
Right.
So if you do the same thing on the rod, just turning your motor, it's going to want to turn. It's going to want to flex front to back, not side to side.
Right.
So you want the strength to be this way, which is how the rod's made. When you have an H-beam rod, it's the other way. It's turned sideways, the weak way.
So it'll flex more back and forth.
So they make the rod wider to get some box strength to it, but they're really, really thin, so they crack and break and they fail. They break in half. They're garbage. Not made right. I-beam's the way to go. The problem is the H-beams are made stronger because they are made out of better materials. Not because they're better design, it's better materials. Okay, now this thing obviously is quite a bit bigger than this one. Now it's the bearing size different. Feels like the bearings are the same. Nope.
Bearings are bigger.
So M8 went bigger again. So the M8 crank pin must be bigger than the twin cam crank pin. I have a twin cam crank pin laying around here right now. Obviously, it's bigger. So the M8 should have a little bit stronger crank than the twin cam.
Yeah, okay. Both sides.
But obviously when you do shit like that, it's not. Now this rod's a lot stronger than this one, because see this is not an X beam. See how much stronger that is? It also looks like it's wider. Quite a bit bigger. So potentially it's a lot stronger motor than a twin cam. But when you do shit like that,
it defeats the purpose.
You kind of lose it, yeah. So it kind of kills it. Now the length. So the difference in diameter here is about a 1/16 of an inch. Oh, look at it.
Yeah, it's very much so longer.
So this M8 has a lot longer rod in it than a twin cam rod.
So what rod is that motor from though? So what stroke is in 88 on a twin cam?
There's two rod lengths and they're only like 9 thou difference. I don't know which way.
And that's more than 9 thou.
I know when I went to the cut rod like this, it's the later rod. But I don't know if it's shorter or longer. I'm not sure. But it's 9 thou difference what S&S is.
So and Harley started doing this cut right here, I'm assuming to cut down on weight?
I'm not sure the theory behind that one.
Yeah, because this design doesn't seem as good as the older flat cut.
You're going to pull the rod apart at high RPM, so that's where you need the strength, and it's not there. So how's that better than the other way? I don't know. I think it has more to do with making the piston better.
And there's no bushing in here like right here.
Well, that's because they're not rebuildable. So they found out that you can get away with making them cheaper.
So now, well, no, because then you just make it weaker.
Okay, so we're at 8 inches here. See, we're over 8 inches. We're like 8 1/8, 8 100 maybe. And these are 7 880 as I recall, but this one looks like it's over 8 inches too. This one looks like it's 8 inches also. Oh, this is the one out of here, that's why. So, this is the one that's twin cam. See, it's not shorter. See, it's not 8. It's back down here.
Yeah.
These are 7 880, I think, or 870, something like that.
That's what it looks like.
Yeah. So these are over 8 inches. These are way under. And then the width is different. The crank pin is different. So this is like 2 1/8 inch hole, as I recall. Looks like it's pretty close to 2 1/8. And this one here is 2 3/16. So they want a 1/16 bigger. They want a lot wider. So everything about it, they stepped up the strength, obviously.
But they cheesed it on the damn
Well, there's no strength here.
Everything else.
Yeah, it chickens up. But see, the M8 is a bigger physical motor. It's got bigger bores, so with the same V angle, you got to go up higher.
Mm-hmm.
That means the rod has to get longer to go up higher. So that's what they did. They made the rod longer, made the whole case bigger. That's why you can make it a bigger motor, because it's made to be a bigger motor. Just like when you take an Evo motor, compare it to this, these things are gigantic compared to an Evo rod. Stock, but if you go to aftermarket rods, they make them 8 inches long and they make them this size.
Right.
They don't make them this size, they make them this size. So this would be the step up in size now and do M8 stuff. But where do you get M8 parts from?
Harley.
No. Can't buy any parts from Harley. You buy a complete crank. They're not rebuildable. There's no extra parts, no spares.
I think the only crap you can buy is the aftermarket. You ain't buying nothing stock, and that's everything being custom cut.
So aftermarket, you take a Harley crank, you push it apart, you rob the crank pin, the bearings, and all that shit out of it. And then you have a custom rod made.
Yeah, you
That's
pretty much have a custom rod.
And you put that into a custom crank, and now you get a stronger crank than what's made right now for regular stuff. You gotta make everything.
So let me ask this: the stroke of a crank, is it based solely off of the length of the rods?
No, rod has no difference. Stroke is a stroke. Stroke is when you go like this.
Oh, okay.
That typically goes in a circle like this.
Right. Okay.
But basically it's going up and down, up and down.
Okay.
Okay, this has no difference. Just like if it's curved, makes no difference either.
Right.
Like on the Evo, they put the curve in it, and it's supposed to be.
Yeah.
Oh, it's got a bent rod. It's stronger. No, that strokes it. No. This rod can be this long. It can be this fucking long. It still moves the same.
The same around the crank.
Stroke.
Okay.
That doesn't change. So when that crank pin right here goes up higher, you get stroke.
Okay. That makes sense. Okay.
So this is a 4 5/8 stroke. See the distance between the center of the hole here, the center hole here? That's your stroke.
So does that mean that that distance is 5/8?
It's 4 5/8, so it's half of that because it goes here, 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 here as it goes in a circle. It goes from here to here. So you add the two together to get 4 5/8.
Okay.
So,
But to determine the stroke
so
of a...
2 3/8 inches between here and here.
What'd you say, 2 and 3 inches?
2 3/8. Oh no,
2 and
it's
3.
2 5/16, excuse me.
2 5/16 from the center of the crank pin to
From
the
center
center.
to center, that's 2 5/8 radius.
Right.
And you go down here for a diameter, you
Right.
pick up the other half because the rod goes,
Okay.
it goes a full circle, doesn't stop, go back up, it goes all the way around.
Mm.
And as it goes around, this goes basically it goes like this.
Right.
But look how weak these rods are compared to this shit.
Yeah, that rod is really, really thin.
And this is weak compared to that one. And look how much shorter this rod is, because this is only 7.4 inches long. This is 7.9, 7.8, somewhere in that area. And now the other one is over 8, so 8 1/16 or something. 8
That's
and
an S&S crank.
Yep. Evo. Alright, well there you go.